Hey guys, welcome back to my garage. In this video of the SYIL X4 to Clearpath Centroid C86 ACCP conversion, I'm going to go over the back panel. It's all wired up. I'm going to go over what needs to be configured. I'll take you for an overhead view and we'll explain everything that I did on the back panel. And then hopefully we'll show the motors moving after the back panel is wired up. Now, after doing all this back panel work here, the very first thing I did before doing anything else is I cleaned everything up. I cleaned up the table, cleaned up the floor. I lightly blew to make sure there were no wire whiskers or anything laying around any PCB boards. That's really important, so take the time to clean everything up. I do have the motor signal cables connected, and I do have the motor power cables connected, but I do not have power connected to the IPC5 or the Centroid Acorn board yet. And the reason behind that is when I power this up, we want to take a meter and verify all our voltages before connecting anything to make sure everything looks good. Let's take a look at this. Okay, hopefully you got a good view of everything here. First of all, I'm going to go over the components on the back panel here. So we have breakers, the breakers for the control, and a breaker for the VFD motor power. 240 volts is coming into this breaker here, and then there's jumpers going to this breaker, and then this breaker is feeding the VFD directly. It has its own ground wire. And then the control breaker is feeding a small set of terminal blocks right here where I can break out power, black and red terminal blocks. And those terminal blocks are also feeding these fuses. These fuses are for cabinet fans. They draw so little current, I wanted to fuse them separately. I'm using 10 amps for the control, and I'm using 6 amps for the VFD. Over here we have a 24 volt power supply. This power supply is for the Power Hub 4, and it is also powering it also provides power for the e-stop contactor. This 24 volt power supply is strictly for Acorn, and it's wired right here. And of course we've got our e-stop contactor with our suppressor, a quench arc suppressor here, and it's a 4-pole contactor. This first normally open contact, when the control is this normal state, that e-stop contactor closes and closes all 4 of these contacts. This auxiliary set, this normally open, you can see it's purple wires, is going to the C86 ACCP to let C86 ACCP know that the control is online. C86 ACCP, the way I configured it, requires a closed contact. So this block has to see a closed contact before it'll enable. All right. The second, this T3, this is going to the VFD. What it does is it breaks the common in case there's an e-stop. It breaks the common, so the forward and reverse, it basically disables the VFD. And then of course these last two, T1, T2, this is power for the drives. So what ends up happening is, here's the DC, 75 volt DC power from IPC-5, and it goes up and it goes into the line side, L1, L2, and then we come out of T1, T2, and we go to the Power Hub 4 right here. And that in turn feeds everything else. Also, we're getting 24 volts from this power supply. That's what these are. This is a common, and this is at 24 volts. Black is common, the yellow is 24 volts. I tend to follow what Centroid does. Yellow wires are 24 volts. So 24 volts is being fed to keep the logic up on the drives. Power Hub 4 keeps the logic side of the drives on, so it can keep position. All right, so I think that pretty much covers it. It's pretty simple. I use the Centroid Acorn system schematic when I do this, and then I'll modify, I'll redline it to suit this particular application. So I think that we covered Power Hub 4, we covered IPC5. Oh, the other thing that I did do, because I'm running on 240 volts, is I removed the jumper from pins 2 and 3, as was required by the instruction sheet. Either you cut it and cap them. I had the tool, so I went ahead and removed the jumper. So the jumper is removed here. Let's see, anything else? Like I said, I've got signal wires to the drives connected. I have power connected, but there is no power to the motors yet until I plug this in, of course, so there's power. And there's no signals yet because I don't have C86 ACCP 24 volts connected. So what I want to do now is I want to go over, this is what I would strongly recommend you do, is disconnect power to everything before you power everything up for the first time. So what we want to do is we want to check incoming power. So I'm going to turn my meter on. I'm going to set it to AC, and then I'm going to check the power coming in. And there's 240 volts, as you can see here. And I'm going to check from phase to ground to make sure I have a good ground. There's 122 there. The next phase, 122. And we'll go ahead and check this other breaker as well. 122, 122. The breakers are off at this time. So I have power, correct power to the line side of my breakers, and I have a good ground here, and I've verified from phase to ground I have my voltage, so I'm good there. So the next step now is I'm going to go ahead and power up these breakers, and you'll see I've got DC okay here on my two power supplies, and the VFD is in its ready state. Okay, so now what we want to do is I want to check my voltage to the IPC5. Okay, I want to check from brown to blue, and you got to be very careful. This is 240 volts. Okay, I've got my voltage, so I'll leave that disconnected for now, and we're going to go switch over to DC. So on my meter I press that and I get DC. Now I'm going to check for DC voltage on my DIN terminals. There's 24 volts. I'm going to check it at my power supplies. 24 volts. 24 volts. Everything looks good at the power supplies. And again, they are registering good voltage. Now we're going to go ahead and check it at the Centroid connector here, power connector. And we have 24 volts, so we're good there. Now we're going to check for 24 volts here at the C86 ACCP power connector. 24 volts, that looks good. So everything looks good. I'm going to go ahead and power this back down. Give it a little bit. Make sure these DC power supply lights are out. Now I'm going to go ahead and plug in my Centroid Acorn, C86 ACCP, and IPC5. Now let's go ahead and power it all back up again. Okay, you can see by the LEDs here that Acorns come up, and I don't know if you can see that or not. It's already booted up. Acorn's flashing at 1 pulse a second. You'd have to look back in here, and I can see the blue LED blinking. That's actually the same thing right there. That if you have the late model hardware, the newest model of Acorn hardware, you'll see the heartbeat right on the board. Everything looks good. Okay, looks like we've got power over here on Power Hub 4. So that looks good. We've got power here. Let's go ahead and check our DC voltage coming out of IPC5. We're still on DC. I'm going to check it right here at these pins. We have 74 volts DC. So everything looks good. Do a visual inspection. Make sure we got no magic smoke. If you do, right away pull that. You'll see I have an e-stop button here, and it's wired up. The Acorn system schematic goes over wiring this. There are 2 contact blocks in there. One contact block simply grounds the e-stop input on Acorn, and the other contact block is in series with relay 1, which is no fault output. 24 volts comes off of here. You see this red wire, it's coming around here, and it goes to the common of relay 1, and then the normally open, this is going to one contact of the e-stop contact block, and then the other end of that block is coming up to the e-stop coil, and then here's our snubber, and the other side of our e-stop coil is going to common. The e-stop button can open the circuit, or no fault 1 can open the circuit. So there's 2 contact blocks again. One is simply grounding the e-stop input. It's going from common to the contact block, from the contact block to input 8. And then the other one, again, we have 24 volts coming down, going to the common side of relay 1, which is going to be assigned no fault 1, and then on the other side is going to the other contact block. These are normally closed contact blocks, and then on the other side of the contact block, it's coming around, goes to this side of the coil of the relay, and from this side of the coil of the relay is going to common to complete that circuit. That's how that works, and that's how you should have it. You'll note that I'm running both the negative and positive through the e-stop relay because I have it, and by doing so, it actually spreads the load across a pair of contacts instead of just one contact. All right, so let's power up the PC and do a little bit of configuring there. All right, let's start up CNC 12. Okay, nothing should have changed. Our setting from our bench tests, it's our starting point for moving forward. Now, if you look at the display here, you see it says emergency stop detected. Well, right now, my e-stop button is released. So if I push it, you say it says release, so that's backwards. So we need to go into utility, and the wizard, which is F7, F10. Okay, let's set our input definitions. So we want to change our e-stop to normally closed. Drive OK is fine. And what we also want to do is we want to assign spindle OK to 6. So let's find spindle OK over here. There it is. I'm going to set that to 6. All right, so that takes care of our inputs. We only have 2 assigned right now, drive OK and spindle OK. And drive OK is coming from C86 ACCP, as you saw previously on the bench test. So that's wired up, and then the fault from the VFD is coming up here. You see these 2 wires, orange and yellow. This orange wire is this orange wire right here going in input 6. This yellow wire is going to common here to be able to complete that circuit. So if there's a fault here, this will open. All right, let's look at our output definitions. Our input definitions are good now. Okay, output definitions, no fault out, that's number 1. 2, 3, not used. 4 is spindle forward. So we're going to go down here to spindle forward. We're going to assign that to 4. Spindle reverse to 5. And then lastly, we need VFD reset out. That's going to be on 6. Okay? So if you look here, this white wire is going to input 1 on the VFD. The black wire is going to input 2 on the VFD. This green wire is going to input 4 on the VFD. So 1 is programmed forward, 2 is programmed reverse, and 4 is programmed for reset, to reset this VFD if there's a fault by cycling the e-stop. All right? So that should be it. So let's go ahead and write the settings to CNC control configuration and see if everything looks good to go. See if we get some motion on our motors. Okay, PLC configuration has changed. The wizard in CNC 12 must be shut down and restarted for PLC changes to apply. Click OK. And it says, please power cycle Acorn board, wait for the heartbeat, and then press OK to continue. So what I'm going to do is I'm going to unplug, and then I'll re-plug in the power connector. Be careful when you do that, if you do it that way. Otherwise, power everything down and restart. Now it says wait for the heartbeat. Okay, we have the heartbeat. Let's see if she comes up. All right, if you look at the display here, it says reset initiated, press reset to clear. So we'll press it and we'll unlock it. And now it says emergency stop released. So at this point, these motor rotors are locked. All right, let's go ahead and see if we have movement. Let's check our x-axis. There's X. See it right here. Cool. And let's look at Y. Cool. Z. Cool. And then our A-axis. Perfect. So we have motion, and everything looks good to go. I don't have the motor connected to the VFD yet, so we really can't test that. Let's try it. Let's go up to the spindle control section of virtual control panel. We'll take it out of auto, and we'll just press go. Okay, so you can see it changing here. And then if I hit 100%, I've already programmed that VFD. It was pre-programmed from the last time I did the control. So you can see it's working there. I'm going to go ahead and reverse it. I'm going to press the counterclockwise button on VCP. And there it's changed. You can also see the reverse LED here is lit. Let's go forward. There you can see the forward LED's lit. So everything's looking pretty good. So now I'm ready to go ahead and cover up all these wireways. And I like this stuff. And it got kind of tight because I was using these cables are all jacketed. But it's going to work. It's going to work. So for the most part, I think Acorn installations can get by with using the small 25 by 25 millimeter. All right, so everything looks good there. The last thing I'm going to do is I'm going to create a report to make sure I have a fresh report. Report backup directory, that's why I'm doing this. And copying the files. Takes a little bit when you do a report backup the first time, and then if you have a USB key in your computer, when you save it again, it's a little bit quicker. All right, let's go back. Okay, that concludes the overview, wiring overview of this back panel, and configuring Acorn for the VFD, spin forward, spin reverse, and VFD reset. And then configuring the spindle OK input and reversing or inverting basically the e-stop input to go from normally open to normally closed, because that's what this is. So that takes care of that. And we got motion on our motors. Okay guys, well I can call this a success. Just to recap, so what we did is with power connectors removed from Acorn, C86 ACCP, the Teknic Clearpath IPC5 power supply. We checked for power, incoming power at the breakers. We turned the breakers on, and then we checked power at the power supplies. We checked it at the 24-volt DC DIN rail mounted terminal blocks. We checked for power, proper 24 volts at Acorn's connector, at C86 ACCP's power connector, and then we checked for 240 volts at the IPC-5. Again, the jumper was removed on IPC5 power supply because I'm running 240 volts. And then we powered everything down, reconnected everything, reconnected all the connectors, powered it all up, and just observed, make sure everything was good. We started CNC 12 and we configured it. We inverted the e-stop input to a normally closed contact. We added the spindle OK input. We configured CNC 12 outputs to make sure that no fault was on 1, spin forward was on 4, spin reverse was on 5, and VFD was on 6. And then we went ahead and we wrote all those settings to the wizard, powered Acorn down as requested by CNC 12. We powered it up, and if you do like I did, if you pull the power connector out of Acorn, be very careful, otherwise just power the back panel down, power it back up. And then we restarted CNC 12 and we tested motor movement and everything looks good. So the next steps, I'm going, now that I've got everything mounted, everything's all configured, now there's going to be penetrations in the cabinet. Of course, this is a used cabinet, so I have to pay attention to where power is going to come in, where my breakers are. I have to get an Ethernet bulkhead connector on it so that I can plug in my Ethernet cable from the PC. If you use an Ethernet bulkhead connector, make sure it's shielded. It has the metal jacket around it on both the in and the output sides of it. But having that simplifies things. I am using the Centroid strain relief in my cabinet. I can run my Ethernet cable through the bottom and into Acorn's Ethernet connector that way, and I may do that. Saves me from drilling the cabinet. Right now I believe my monitor and PC are going to be in the outside of the cabinet. I know my VFD cable's coming in from the top, so that won't be an issue. It comes from the top of the cabinet and then it'll swing around and go into the VFD. So anyway, the point is you want to make sure you drill your cabinet, do all your modifications to your cabinet before you mount the back panel, because the last thing you really want to do is mount the back panel, be drilling into your cabinet and have the metal swarf going all over the place and possibly land on one of these components and create bad things, short, etc. If you have any questions about this back panel, or if there's something I left out, please leave a comment below and I'll try and answer it. I try and answer all my comments as time permits. And I think I pretty much well covered everything. Again, I strongly suggest you use the Acorn system schematic as a guide when wiring something up like this, because it shows how to wire your e-stop button contactors, the e-stop contactor, it's called CNT1 on the schematic, and so forth. It does not cover the Power Hub 4 because that's a little bit unique to this. Go to a Staples. I go to Staples and I actually email the schematic to them, and they print out a full-size sheet, and I have a full-size, I think it's a 24 by 36 sheet, and then I modify that sheet. So, and I'll make any corrections or additions by using a red pen and marking things out. So make sure you try and put some documentation in your cabinet, because you might, somewhere down the road, you may have to service it and you won't remember what you did. So having some documentation helps. I'll take a overhead view picture of this, and then I'll use Adobe and I'll use the commenting to comment what each component is, and maybe some rough description of how it's integrated on the back panel, how it's wired up. All right, guys, the next video, I'm going to get my cabinet wired up. I have to, and I'm going to go ahead and mount up all the motors. We still have the issue with the Y-axis servo being behind the cabinet, but I discovered that the way SYIL designed the cabinet, you could take the 2 bolts out of the bottom of the cabinet and hinge it forward so you have access to it. So it's not ideal, and you can't take the cabinet off completely, but you can get really close where you can get there to service the motor. You can reach the 4 mounting bolts, and then from the front, underneath the bellows cover over the ways, you can loosen the coupler clamp on the motor shaft, and you could get that motor out. But that said, I believe I'm going to leave a USB cable connected to that motor. I haven't decided yet, because that's the only way, without having to unbolt the cabinet and get to it, that's the only way to get data out of that drive if there's an issue, or if I got to retune it or something. So I think in my case it's better off just to bring that USB cable off that motor and then coil it up in the bottom of the cabinet. All right, guys, that's it for this video. Again, I'll bring you back once that back panel is mounted. I'll decide whether or not I'm going to test and tune that y-axis before mounting the cabinet, or if I feel like everything's good, I'll go ahead and mount the cabinet, mount the back panel, leave that USB cable out so we can tune it and go from there. So I hope you enjoyed. Again, if you got any comments or questions, put them down below. Talk to you soon.